So we're going to look at reciprocal functions, which is 1 over f of x. And just like square root graphs where you just square rooted the y value, the same thing with reciprocal graphs. Very simply, all that's happening is your y value from your original function becomes 1 over y. So it's a really similar idea to a lot of the graph stuff that we've been doing. So that's the rule. We could say we're all done because I don't have to tell you anything more. Just go out and find out what happens. But the weird thing about reciprocal graphs is that when you draw them, they end up looking quite different. So we're going to look at some special things that happen. So just like when you're doing the square root of a graph, you would want to graph the bottom function first. What does f of x look like? Okay? Now, an important thing that happens is, let's say f of x was x squared minus 4. In fact, is that our first example? It is. Okay. So on our first example here that you have on the other sheet, we have the bottom function being x squared minus 4, and that's graphed for us. Now, if all the y values change to be 1 over y, the first thing that we're going to look at is what happens when the y value is 0. Okay, so whenever your parent function, f of x, has x-intercepts, in this case, can you see that this has f, if you factored it, you'd get x-intercepts at 2 and negative 2. And if you have x-intercepts, the y value is going to be 0. Now, if the rule for 1 over f of x is you just write 1 over your y value, can you see that you're going to have a problem wherever there was x-intercepts? Well, in all reciprocal graphs, wherever your parent function has x-intercepts, you're going to draw asymptotes. And with a parabola, you already did this last year in grade 11. Wherever there was x-intercepts, you're going to draw an asymptote. Then, when you did this in grade 11, you always had an asymptote at y equals 0. But it doesn't always have to have a horizontal asymptote at y equals 0. In this case, it's only going to happen if your original graph, your f of x graph, goes up to infinity or down to negative infinity. Then you will have an asymptote at y equals 0 as well. So for each of these things, the bold part is like the shortened version of what's important. And then what I've written after that has given some instructions or some reasoning why it happens. Like, why do you have an asymptote at y equals 0 if your original graph gets really, really big? Well, if the y values keep getting bigger and bigger, like here we have 10,000, when you do the reciprocal, you'd have 1 over 10,000. So the bigger your value gets, when you do 1 divided by that value, the smaller it gets and the closer it gets to 0. Okay, I'm just going to switch number 4 and number 5. Okay, you can put this in. This is much easier to remember. Something we do all the time is just graph nice points. Okay, if you know a point on your original graph, you change the y value to 1 over y. That'll simplify steps 4 and 5. You can graph nice points. So here, if you have the point 3, 1, that's a nice point. We change the y value to 1 over 1, and we get 3, 1. So in part 4, they're looking at points that don't change. If you want to highlight this, of course my highlighter, oh, it works right away. Fancy day. points that don't change are called invariant points. So if your y value is 1 or 1, 1 or negative 1, does it make sense when you do 1 over 1 or 1 over negative 1 that you would still get the same value? And so those points won't change. Then finally, after you've done a bunch of nice points and you have your asymptotes, you can just draw your graph towards your asymptotes. So we've done a quick explanation of all of the steps. It's kind of hard to visualize it as you're just talking about the steps. So what we're going to do now is discuss through some examples what you're going to do. And I'll actually even make it simpler than the examples here. In the examples here, all the steps are listed separately. So if you wanted to visualize what one step after another looks like, but when you're actually doing it, this is what it would look like. You would draw your original function first. So here is our original function. It has the vertex at 0, -4, an x-intercept at 2, 0, 1 at -2, 0. Could you find other nice points? Yes, right? You could plug in 3. You would get 3, 5. Same thing over here, you'd get -3, 5. You could plug in 1. Now, once you've got your original graph, unlike square root graphs where it made sense to draw it on the same one, for reciprocal graphs, it makes sense to draw it beside. And if we want to simplify our 6 steps down to 3, okay? Step 1, draw all your asymptotes, horizontal and vertical. I guess step 0, we still need the original graph. I shouldn't take that out. Okay. Step 0. Step 1, asymptotes. Step 2, nice points. Step 3, graph. So, where will we have asymptotes? Start off with vertical asymptotes. You're going to have a vertical asymptote wherever there's a non-permissible value. Can't divide by 0. So if your y value is equal to 0 on your original function, then you would have 1 over 0 on your reciprocal function. And so at 2 and -2, take out a red pen, label them x equals 2, x equals -2. For your horizontal asymptote, ask yourself, does my graph go up forever or down forever? In other words, do I ever get really, really big y values, either really, really big positive y values or really, really big negative y values? In this case, the answer is yes. We have arrows saying that the graph goes up forever. And so you will have a horizontal asymptote at y equals 0. You've drawn your asymptotes. Next, let's look at some nice points. Okay? What happens to 0, -4? It becomes 0, 1 over -4. What happens to 3, 5? It becomes 3, 1 over 5. -3, 5. -3, 1 over 5. Could we put another point on here? Sure. We could have the point 1, comma, -3. What happens to that point? 1, comma, 1 over -3. So whatever points are on our original graph, on our reciprocal graph, they just become 1 over that y value. And you could do as many or as few as you like. But just like when we were graphing our rational functions unit, you need to have at least one point in each of the sections. And now that I've graphed it, part 3, draw your graph. Well, your graph goes towards asymptotes. And with a reciprocal graph, any graph that's 1 over, does it make sense that you will never have x-intercepts if you have 1 over something? Because for an x-intercept to happen, you need y equal to 0. And for y equal to 0, the only time a fraction is equal to 0 is if the numerator is equal to 0, and the numerator is always 1. So there's no x-intercepts, you've got your asymptotes, and so then you just need to draw your graph towards your asymptotes in the end. This graph you did in grade 11. All right? I think the math teachers at our school like to give them special names. Do you remember the name of this one? Sad clown face. Kind of looked like it's got a sad face. Aww, right there. Yes, maybe remember that? So we just did this example again. It's the same as what you did in grade 11. In grade 11, though, in your denominator was only lines and parabolas. The only difference in grade 12 is now we could put anything on the bottom and follow these 3 steps. Have your original graph isn't a step because sometimes that's given. But to graph it, you need to do your asymptotes, nice points, and then just draw your graph towards your asymptotes. So it's not super complicated, but let's look at another one. Another one that you would have done last year in grade 11. Y equals x squared plus 1. I'm going to label some nice points on this graph. X squared, you'd have 1, 2, -1, 2, 2, 5, -2, 5. Then right beside it, we'll go through our steps. Step 1, asymptotes. We have asymptotes whenever our original graph had x-intercepts for non-permissible values. Do we have any x-intercepts on our original graph? No. Since we have no x-intercepts, there's no non-permissible values, there will be no vertical asymptotes on our graph. Horizontal asymptotes. Does our graph have very, very big y values? Yes. Okay. So we're going to have an asymptote at y equals 0. A review of our rational functions unit. If the degree is bigger on the bottom, you always had an asymptote at y equals 0. So now we're sort of doing the same thing again, just in a different context. In a reciprocal graph, we're talking about y values getting big. That's why we had an asymptote at y equals 0. In our rational functions unit, we said that whenever the degree is larger in your denominator, you have an asymptote at y equals 0. So sometimes it's kind of nice when these concepts come together in more than one unit. Okay, step 1, asymptotes. Step 2, nice points. What's going to happen to 0, 1? It's going to become 0, 1 over 1, which is still 0, 1. What's going to happen to 1, comma 2? It's going to become 1, comma 1 over 2. What's going to happen to 2, comma 5? It's going to become 2, comma 1 over 5. Negative 1, comma 2. Negative 1, comma 1 over 2. And negative 2, comma 1 over 5. So we did 5 nice points. Step 3, can you draw your graph towards the asymptotes? Towards the asymptotes? Yes. What did you call this one in grade 11? Speed bump? So again, draw your asymptotes, find nice points. The only thing that's changing in a 1 over graph is that your y values change from y to 1 over y. And then draw your graph towards the asymptotes. We do this example to see, well, what happens when there is no x-intercepts, when I don't have vertical asymptotes. Finally, let's do one that's new. 1 over the square root of x plus 4. So step 1, draw your original graph. I've got 3 nice points labeled. Then right beside it, we'll draw the reciprocal graph. Step 1, asymptotes. Will we have a vertical asymptote? Do we have any non-permissible values? You can either look at the equation or look at this graph. Can you see that at your x-intercept, negative 4 comma 0, 1 over 0 would be a problem? Can you see from the original equation that plugging in negative 4 is going to be a problem? Cause you to divide by 0. So we draw an asymptote at x equals negative 4. Horizontal asymptote. Does the square root graph keep getting bigger and bigger and bigger? It does. So we will have an asymptote at y equals 0. Step 2, nice points. What's going to happen to negative 3 comma 1? And I'm going to keep writing this, but if you want, you can just write negative 3 comma 1. But I'm going to write 1 over 1 just to remind ourselves that that's what we're always doing. We're always taking the y value and doing 1 over that y value. So when I get to 0 comma 2, I now have 0 comma 1 over 2. If you wanted to do another nice point, you can. You can do as many nice points as you want. Can you see, though, that you probably have enough to graph it? It's going to go towards our asymptote here and towards our asymptote there. We're getting close to the exam. Do you remember this E10 error? If you drew it like this and then had it swoop up a little bit? Right? When you have an asymptote, it needs to keep getting closer and closer to that asymptote. If it swoops up or swoops away from it, just because you're like, woohoo, I'm done this question, right? That's going to cause them to take off a half mark on your exam. Let's get rid of that purple. Why is there nothing to the left of x equals negative 4? Because you can't. They're non-existent to begin with. Yes.
I was just wondering, would the only example of not having to do a y equals 0 asymptote be if there weren't arrows on the ends of a graph?
Yeah, or we're going to do like a sine graph. It has arrows on the end, but do you see how sine graph never goes past 1 or negative 1? Yeah. So it's not necessarily just the arrows, but the arrow not going up forever. You could also have a horizontal line with an arrow on it, but that one would still work. So we're going to look at, oh, this one I still put an arrow on the end. But if I didn't have an arrow on the end here, this one would have no asymptote. But we will see it because we do sine and cosine graphs coming up. So then a favorite way that the exam likes to ask reciprocal graphs is they make up some graph and give it to you, which technically makes the question easier because you don't have to do step 0. You don't have to graph it on your own first. That graph has been given to you. So if that graph has been given to you, then right beside it here, okay, step 1, do we have any non-permissible values? Do we have any x-intercepts? Yes, we have one. We have one at -1, one at 2. Wow. And 1, 2, 3, 4, 5, another one at 5. X equals 2, x equals 5, and x equals -1. There is an arrowhead on the right-hand side showing that this graph goes up forever. So we do have a horizontal asymptote at y equals 0. If that arrowhead wasn't there and it stopped, then you wouldn't graph your horizontal asymptote. Now, one of the reasons I have this one is to show you that horizontal lines, like from -5 to -2, do you see that there's a horizontal line here? Since you do 1 over that value, so this will be -5, comma 1 over -1, and -2, comma 1 over -1, it will stay a horizontal line. Because all the y values would change, but change to the same thing. We have another point here, 0, comma 1. That's going to be 0, comma 1. We have 4, -1. 4, -1. We have 6, comma 1. That'll be 6, comma 1 over 1, which is 6, comma 1. Do we have enough information to graph this? Yes. Okay. First of all, in this left-hand section where we have the straight line, sometimes you might wonder, well, I don't know, should I go up or should I go down? Couple of reasons why you need to go down towards the asymptote. One, do you see that if you went up, you would have an x-intercept? In a reciprocal graph that's 1 over something, you have no x-intercepts. So that's one reason that I know that it needs to go down. If you were unsure, you can always add more nice points. For example, if I look here at that blue point, it looks like at that blue point my y value is a half. What's the reciprocal of a half? Or sorry, negative a half, sorry. My y value would be negative a half. If I do the reciprocal of negative a half, I would get -2 over 1. And -2 also means that it would need to go down. In this section, same idea. These will have to go up towards your asymptotes. In this section, down towards your asymptotes. And in this section, towards both of your asymptotes there. So step 3 in graphing, you just need to show your graph going towards the asymptotes.